The room fell silent as NASA scientists carefully lifted the lid of the space capsule. Hearts pounded with anticipation. This wasn't just any container, but one carrying fragments from the beginning of time itself. As light flooded the interior of the OSIRIS-REx sample return canister, gasps echoed through the Johnson Space Center laboratory. Before them lay a blanket of mysterious black dust scattered across the avionics deck material that had journeyed for 0.5 billion years through space and time to reach their trembling hands. "This is unprecedented," whispered Dr. Daniela Loretta, her voice quivering with emotion. "We're looking at pristine matter from the dawn of our solar system." The scene unfolding in Houston on September 26, 2023, marked a pivotal moment in humanity's quest to understand our cosmic origins. The sample from asteroid Bennu, a primordial relic orbiting our sun, had not only arrived safely after its 7-year space odyssey, but brought with it an unexpected bounty. The collection weighed 100 grams more than anticipated, a surplus that both puzzled and thrilled the scientific community. Bennu isn't just any space rock. This carbon-rich asteroid serves as a time capsule from when our solar system was nothing more than swirling gas and dust. Unlike Earth, which has undergone billions of years of geological transformation, Bennu remains largely unchanged since its formation, a pristine witness to our cosmic beginnings. When we study Bennu, we're essentially reading the first pages of our solar system's autobiography, explained Dr. Michael Drake, his eyes reflecting the wonder of a scientist confronting the universe's greatest mysteries. These samples could answer fundamental questions about where we came from and how life began on Earth. The journey to this moment began on September 8, 2016, when the OSIRIS-REx spacecraft thundered into the Florida sky atop an Atlas V rocket. Its mission was threefold: collect samples from Bennu's ancient surface, characterize the asteroid's composition and geology, and assess its potential threat to Earth. This last objective carries particular weight. Bennu is classified as a potentially hazardous asteroid, with a planned close encounter with Earth in September 2135. While the probability remains low, calculations suggest Bennu could pass through what scientists call gravitational keyholes, regions of space where Earth's gravity could alter the asteroid's trajectory, enough to put it on a collision course with our planet later in the 22nd century. Understanding Bennu's composition and behavior isn't merely academic curiosity, it's a matter of planetary defense. The asteroid experiences the Yarkovsky effect, a phenomenon where sunlight heats its surface, creating a slight but meaningful thrust as it rotates and releases that heat. This subtle force can significantly alter an asteroid's path over time, making precise predictions challenging. For 2 years and for months, OSIRIS-REx soared through the void of space, covering 1.4 billion miles before finally reaching its destination in December 2018. The spacecraft entered orbit around Bennu, beginning a meticulous survey of the asteroid's rugged terrain. What they discovered was far from the smooth, sandy surface they had anticipated. It was like looking at a landscape of boulders and rubble, recalled mission specialist Dr. Hannah Martinez. Finding a safe spot to collect our sample seemed almost impossible at first. After months of careful mapping and deliberation, the team selected Nightingale, a relatively clear area in Bennu's northern hemisphere, as their target. On October 20, 2020, humanity held its collective breath as OSIRIS-REx descended toward the asteroid's surface. There would be no second chances. The spacecraft hovered just meters above Bennu's dark surface. The touch-and-go sample acquisition mechanism, TAGSAM, extended from OSIRIS-REx like a careful hand reaching for a precious gem. In the control room on Earth, no one dared to breathe. "Contact confirmed," came the announcement, breaking the tense silence. For 9 brief seconds, shorter than it takes to read this sentence aloud, the spacecraft touched the ancient asteroid. A burst of nitrogen gas stirred up the surface material, capturing fragments of Bennu's 4.5 billion year history. What happened next exceeded everyone's wildest hopes. Instead of the required minimum of 60 grams, TAGSAM collected nearly 300 grams of material, 5 times more than expected. The abundance was so great that larger rocks jammed the collection chamber's flap, causing some precious particles to escape back into space. "We need to secure what we have now," Dr. Loretta decided urgently. The team skipped the planned sample measurement and sealed the container immediately to prevent further loss. Despite this quick action, they had captured far more than needed for their research. On May 10, 2021, OSIRIS-REx bid farewell to Bennu and began its long journey home. For 2.5 years, it carried its irreplaceable cargo through the dangers of space radiation, micrometeorites, and the vast emptiness between worlds. Finally, on September 24, 2023, the spacecraft approached Earth and released its sample capsule, plunging through our atmosphere at a blistering 12 kilometers per second. The capsule became a brief, brilliant shooting star before deploying its parachute and floating gently down to the Utah desert. Recovery teams raced to retrieve the capsule, treating it with the care usually reserved for newborn babies. Every precaution was taken to prevent contamination. The samples had remained pristine for billions of years, and scientists weren't about to ruin them in the final moments. When the canister was finally opened at Johnson Space Center, scientists made a startling discovery. Black dust had somehow escaped the sealed sample container and spread throughout the canister, even reaching the avionics deck where the electronics were housed. "This is completely unexpected," Dr. Martinez whispered, carefully documenting every speck. "The dust appears to have found its way through microscopic gaps between the lid and body of the container." The mystery deepened as scientists pieced together what happened. When OSIRIS-REx touched down on Bennu, it created a shockwave that rippled across the asteroid's surface. This disturbance launched additional material into space, some of which clung to the spacecraft as it retreated. Some particles even slipped into the sample canister through its open flap, mixing with the material collected by Tagsum. The total sample now weighed approximately 400 grams, a cosmic treasure trove, beyond their initial expectations. Despite the unexpected distribution, the sample remained in excellent condition, having faced minimal exposure to heat or contamination during its return journey. Now came the delicate task of recovery. Scientists used specialized tools to carefully collect every precious grain from the avionics deck, without damaging the sensitive electronics. Each speck of dust was documented and catalogued not just for scientific records, but because these tiny fragments might hold answers to humanity's biggest questions. "These aren't just rocks," explained Dr. Drake as he carefully transferred a grain smaller than a pinhead into a sterile container. "Each particle is a message from the early solar system, telling us about the conditions that eventually led to Earth and life itself." But why would space agencies spend billions of dollars to visit a half-mile-wide rock floating in space? The answer lies in what asteroids like Bennu represent: time capsules. From the birth of our solar system, unlike Earth, which has been transformed by billions of years of geological processes, asteroids remain largely unchanged since their formation. As scientists began their analysis, they discovered something that made their hands tremble with excitement. Within Bennu's dust lay organic molecules, the very building blocks of life. Could these compounds hold the key to understanding how life began on Earth? "We've found them," Dr. Loretta announced, her voice barely above a whisper as she stared into the microscope. "Organic compounds, carbon structures, and even amino acids, the fundamental building blocks of life." The room erupted in quiet celebration. These weren't just any molecules, but the very chemical foundations that make life possible. Their presence in Bennu's ancient material suggested something profound. The ingredients for life existed in our solar system long before Earth formed. "This changes everything about how we understand our origins," Dr. Drake explained, carefully labeling another sample container. "It's possible that asteroids like Bennu delivered these essential compounds to early Earth, seeding our planet with the chemistry needed for life to emerge." The discovery echoed findings from another asteroid mission. In 2020, Japan's Hayabusa 2 spacecraft had returned samples from asteroid Ryugu, revealing similar organic molecules including amino acids. But Bennu's sample was larger and potentially more diverse, offering an unprecedented window into our cosmic heritage. As analysis continued, scientists discovered water-bearing minerals within the sample. These minerals suggested that liquid water once flowed on Bennu's parent body, likely a much larger asteroid that broke apart billions of years ago. This finding strengthened theories that asteroids may have delivered not only life as building blocks to Earth, but also much of our planet as water. "We're essentially holding the ingredients that made Earth habitable," explained Dr. Martinez, carefully preserving another precious grain. "These samples tell us about the chemistry that existed before our planet formed, chemistry that eventually led to us." The work proceeded meticulously, with each tiny fragment treated as irreplaceable, which indeed it was. Scientists would spend years, perhaps decades, studying these samples, using technologies not yet invented to reveal secrets still hidden within the ancient dust. But OSIRIS-REx's mission wasn't over. The spacecraft itself, having delivered its precious cargo, received new orders and a new name, OSIRIS-APEX. Its next destination would be another potentially hazardous asteroid named Apophis, measuring about 340 meters across. Apophis will make an extremely close approach to Earth in April 2029. While it won't hit our planet during this flyby, scientists want to understand how Earth's gravity might affect its future path. A Cyrus Apex will arrive at Apophis shortly after this close encounter, spending 18 months studying the asteroid from orbit. What we learn from Bennu and Apophis could literally save our planet someday, Dr. Drake noted. If we ever need to deflect an asteroid on a collision course with Earth, we'll need to understand exactly what these objects are made of, and how they respond to outside forces. As scientists continued their work with Bennu's sample, public interest in the mission soared. Schools organized special lessons about asteroids. Museums created exhibits explaining the significance of the samples, and a new generation of young minds became inspired to pursue careers in space. Science, this isn't just about understanding our past, Dr. Loretta told a group of wide-eyed students visiting the lab. It's about securing our future. The more we learn about our solar system, the better equipped we are to protect our planet and perhaps someday expand beyond it. Meanwhile, in laboratories across the world, researchers began receiving tiny allocations of Bennu material for specialized studies. Each grain, some smaller than a human hair, represented an opportunity to answer questions that had puzzled humanity for centuries. One team discovered minerals that could only have formed in the presence of liquid water. Another found complex carbon, compounds that might represent precursors to the molecules that drive life on Earth. A third identified isotopic signatures that could help pinpoint exactly when and where in the early solar system Bennu formed. As these discoveries accumulated, a more complete picture of our cosmic neighborhood began to emerge. Bennu wasn't just a scientific curiosity, it was a messenger from our distant past, carrying clues about how our solar system evolved from a swirling cloud of gas and dust into the planets we know today. And somewhere in those ancient grains might lie the answer to humanity's most profound question. Are we alone in the universe? If the building blocks of life formed naturally in the early solar system and were delivered to Earth by asteroids, might the same process have occurred elsewhere? As the sun set outside the laboratory windows, Dr. Martinez carefully sealed another sample container and made a final entry in her research log. Tomorrow would bring new tests, new discoveries, and perhaps new questions, but for tonight, she allowed herself a moment to contemplate the journey of the dust before her. From the birth of our solar system to this laboratory, carrying secrets that had waited billions of years to be revealed,